Well, massive welcome to everyone to Coffee Buddies. It feels like the end of a festival. Those of you who have been to Glastonbury, it feels like the end of the week. The tents are being put up, but we've got one fantastic act still to come. And the Coffee Buddies is all about meeting people. It's improving the chances of business by increasing serendipity, and we're all about informing, entertaining, and enjoying ourselves, and educating ourselves. And we're lucky enough to have Peter come to talk to us today. He will introduce himself in a minute, but this week I think has been a week of data. There's always been data in biotech, but there's something else that seems to be happening, which is, I think there's a big push about greater insight out of data, that we possibly in the past have recorded things but not really got enough out of that recording. And that's been the theme of the week. And I think Peter, we're lucky enough to have him, will continue that theme. And Peter, welcome to you. Maybe you could tell us who you are, what you do, and what you are contributing to the ecosystem, really.
Yeah, so good afternoon, everyone. For me, it's good morning because I'm located in Washington, D.C. And my background is I'm a chemist by training. I did focus pretty early on more computational methods, and then did a postdoc together with the computational chemistry group at Pfizer in Sandwich. I think Sandwich no longer exists, doesn't it?
It's
I seem to have a history of working with groups
exists, but the Pfizer group have gone. It's an ecosystem, but we didn't get rid of Sandwich. It's still there firmly.
Yeah, I seem to have a tendency of working on sites or working with sites where it close after I leave.
Well, we won't invite you over there.
Yeah, so I studied chemistry in Erlangen in Germany and at University College in London for 1 year there. And after my studies and postdoc, I worked at Novartis for almost 20 years. So the first 10 years I worked at Horsham, again, a site where the research closed afterwards. So I left. Then 4 years in Basel and 4 years in Singapore. And Singapore is the third site that closed after.
Oh, good. You're obviously famous for something.
Yeah. So I worked in several disease areas, in respiratory diseases as a computational chemist, in gastrointestinal diseases. And then in Singapore, I worked on neglected tropical diseases like malaria, African sleeping sickness, dengue, and cryptosporidiosis. In addition to that, I also did cheminformatics development within Novartis. So we developed a data warehouse solution, and I also provided several models that were used by the chemists. 6 years ago, I joined CDD, and for those of you who don't know CDD, I have a couple slides that kind of give an overview of what we do. So if I could share them with you.
Put those up, Peter, and we can just see what it's about.
Okay, so they're really very basic. So CDD has been around for quite a long time now. So we almost have our 20th anniversary. It was founded in 2004 in San Francisco, and it provides a cloud-based data management and discovery platforms. The advantage of having a cloud-based solution is that if you come in as a customer, we can set you up in a couple of days and you are ready to go. So it's really great also for collaborations because of the cloud-based solution. And as you can see on the map, CDD has several locations in America, in San Francisco, obviously, then in North America, Northeast America, some Mariana in Europe. And then we also have sites in Japan and Korea, I think. Korea and Singapore and Philippines. And as I learned today, also someone in South America. What CDD Vault does is provides you a solution where you can store all your research data. So you can store chemical compound, register compounds, and biological entities. You can now also, and this is something that we developed, store mixtures that could be interesting for people who do drug development or maybe also in materials. And a whole, basically, all your screening data and so on. If you have, in order to integrate it well into your own IT infrastructure, we also have a RESTful API, which allows you to access all the data and bring them out into your own system. Okay, so that's essentially the slides that I wanted to share.
Yeah, I mean, if we leave just that slide, we just leave it on a bit there. I mean, I think that shows very, very nicely the breadth of your or the span of your technology's ability, but it also is much more than just storage, isn't it? It's interpretation, really, that you're very keen on what I would call transversal interpretation. In other words, interpretation across all the blocks of data. Is that true?
Yeah, that's true. So if you look at the typical research data, you can always kind of put it into a table. I know a lot of people don't like putting things in a table, but where you have, as a rows, you have all the chemical structures, and at the column you have the biological structures. And what we developed as part of the research informatics groups was a way of annotating the assays so that you can have rich information for each of your columns, so for each of your biological assays. And that opens up ways of organizing your biological information in the same way as you can organize your chemical information. So in chemistry, you know that we can do substructure searches, similarity searches. We can do something very similar now also with the assays. So we can look at which assays are similar because we describe assays using defined dictionaries, so-called ontologies. And that allows us to navigate chemical space and biological space at the same time.
And would you say that having this, that it simplifies the complexity that we've all suffered from for many years? Oh, we've got it there. Complexity simplified. Yes.
Yeah, that's the tagline.
Good. It's God, I'm one step ahead of you all.
Yeah, that's our tagline.
Yeah. But I suppose one of my questions is, if you take is your customer base principally drug discovery?
Yes.
Yeah. So, I mean, I suppose my question to you in drug discovery is, are we doing more experiments than we did or less? Is the amount of data we're generating more or less?
Well, it grew. It grows and grows and grows. I remember the first high throughput screen that we ran at Novartis, that I was involved in at Novartis, was 200,000 structures. Now it's more in the millions. So data increase, and you usually broaden the panel of assays that you run. And then, of course, you have all the additional information that comes from the outside, like genomic information, pathways information, and so on.
Do you think, is this causing an issue to biotech who can't possibly compete with data generation? So although they might be doing very well, that actually what we're seeing in the sector is those who are generating buckets of data have a competitive advantage over those who can't.
That's a very good question.
Sure is what the data
I,
proves.
I'm not sure if I have an answer to that, but you're right. I mean, how can a small company compete with a 2 million corporate archive that you can screen for a new target? On the other hand, of course, you have the computational tools that we can use for hit finding, for virtual screening. They are now much more easily available because we also, in addition to all the increase in data, we've also seen an increase in the open source availability of computational tools over the years.
But you know,
And
Peter,
so,
I'm interested in whether biotech is threatened into the future, because you know the reason we if you believe that there's a reason for biotech, we set it up originally for creativity. Now, I suppose my question now is, in a very rich data environment where biotech can't generate the amount, that actually pharma starts to take on a more senior position into the future. Because, I mean, this sort of technology you've got is awesome because it allows you to navigate everything you've got in your cupboard, of which is enormous, isn't it?
yes. But of course, the question is, a big pharma company always has more data available. But having more data available is not the end, the end of it. I mean, you need good scientists, you need creative scientists, and the promise that that is out there, that AI changes drug discovery and makes it, you know, you get to a drug in a couple months. I really am cautious that that is not necessarily the case. Because we've seen promises like this in the past and they never really translated into reality.
I mean, are you finding, you know, because if you go back to most of the things I've ever worked with got poured down the sink because they didn't work. So the question, I suppose, is is it possible to retrieve the years gone by data and then use this tool to really interrogate it, or is it so, you know, badly archived that you can't do it? Is this for future thinking, or is this past, enabling past stuff?
So enabling past is so the problem is that past data are very often not properly annotated. So you don't necessarily know exactly what is in there. And so annotating now is a good for the future. One of the developments that we did as part of this, our assay annotations research, was to devise ways of semi-automating assay annotation, so you could learn from, because what you have free text documents that describe your assays, but you don't have them in a defined dictionary, so it makes it difficult. And but by using something like natural language processing, you can see if you can annotate historical assays. But that's a really difficult task, and maybe something like GPT-4 can help in that. But I think there's a big trust issue. At least I have a big trust issue to these models. Because they know if they just make something up if they don't know.
Yeah. I mean, can you think of the next steps that are going to happen in digitizing data and unwinding complexity? I mean, we've had some very fascinating discussions from Remco on AI. Do you see in the next few years a real change in the way that we do drug discovery? Is modern drug discovery, because I've been running a series with Graham and we're still frustrated trying to understand what is modern drug discovery. But do you see that in the next few years modern drug discovery is going to be much more efficient? Do you see that you're going to be having lots more candidates? You know, are we going to enter a lot more into the clinic?
I probably have a bit of a cynical view of that.
Oh no, but we like cynical because it's dramatic.
Because you know, if you screen more, you have more candidates, you have more work.
Yes, and
you still have to do the work. And of course, you can by mining historical data, you can maybe identify the candidates that are just interfering with your essays and weed them out quickly. But in the end, you still have the problem to develop your hit into a lead and then to optimize it further. And then where the crux is that the properties that you need to optimize in the end that require something like tox or bioavailability, there the database to build models is not that great either.
Yes.
And I mean, here I think it would be good if, because I always call this a bit pre-competitive information, where everybody would benefit from having a shared base of sharing that information. And because then, of course, you have a broader data set to learn from. But that is difficult to convince big pharma, because they obviously have the large data set.
No, that is really, really good. Is there anything else you'd like to sort of share with the group on your thoughts on CDD Vault? Is there anything else you'd like to share?
Well, maybe one thing that I think is interesting with CDD Vault is that it's a system that is driven a lot. The development of the system is driven a lot by the customers. So which of course sounds a bit stupid, because I guess every software company will say that, but I've seen that. And so in addition to that, these developments, so for example, we added the managing of biological data into the system, and we now also add the assay annotations. But in addition to these developments that come from customer requests, we also have some ongoing activities in our research informatics groups that tries to bring in novel technology that can improve the product ultimately improve the product. So we had, for example, projects on assay annotations. I already mentioned that now gets incorporated into our main product. We had a research project on chemical space navigation that was incorporated into our visualization software. And the mixtures is something that Alex Clark developed together with the INSHI group, which is a global group that tries to standardize how to label chemical compounds. And he extended that with the group together into mixtures, and we add mixtures now as an entity into our system. And we also had deep learning projects ongoing, and I currently work on incorporating those into our product. But the question is, of course, how do you incorporate something that it becomes a useful tool for the customers?
Yeah.
And so
interesting.
I think we've got some questions in the audience, so if we could take the screen off.
We take down the screen, and I'll just thank. Can I just bring up everybody? Let me just thank you for a fantastic insights, Peter. So maybe we should thank Peter in our traditional way, and then